for section 4.4b, this is going to be inequalities working in two triangles. So for this one, imagine a gate between a fence post A and B, as shown below. As the gate swings open, imagine that a triangle ABC is formed, in which C is located at the end of the door, so that the gate is side AC, which you can see up here. This would be point C, and we would form a triangle with these 3 points. As the gate opens wider, you'll notice that BC keeps increasing in measurement, even though the other two sides of the triangle, BA and CA, stay constant between the two triangles. Those never change. We call this the hinge theorem. So what the hinge theorem is if two sides of a triangle are congruent to two sides of a second triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So what that means is, if you look at the two triangles below, you'll notice there are two pairs of congruent sides between the triangles. And then if we look at the angle in between them, oh, that's too dark. We have 88 degrees and 35 degrees. Because these angles are where these two congruent sides meet, at point V and at point R, and we know 88 is larger than 35, we know side XW is going to be larger than side ST. And that's because 88 is larger than 35. The converse of the theorem is also true. So if we are given two congruent sides between the two triangles, again, and we know that the side across from them, for both of them, whichever one has the largest third side is going to have the largest angle across from it. So we know the measure of angle C is going to be greater than the measure of angle F, because C is across from the larger side. And this is, again, only true when you have the two congruent sides between the triangles. And we can only do it for the angle that is included between the two. Okay. So let's do an example. In which of the following statements are true? So first, let's look at these pictures. We are given the two congruent sides between the triangles, and we know that angle O is 70, and we know the measure of angle A is 90 degrees. So right away, we should be able to identify that the measure of angle A is greater than the measure of angle O, which means the side across from angle A, which is SK, is going to be greater than the side across from O, which is UY. So let's look through the statements they give us. They told us, for number one, that AS is less than YU. Do we have enough information for that one? Nope. The second one is SK is greater than YU, which you notice is what we said over here. So we know B is true, which is the opposite of C, so it couldn't have been C. And then they also said AK is equal to YU, which we know is not true because they did not mark them congruent in the two triangles. So we know that this one is also false. There you go. Our next example. Given that ST is congruent to PR, and they already have it marked on our picture, what relationship can we conclude about angle PST, which is this angle here, and angle SPR, which is this angle here? So before we can conclude anything, we need to look at the two triangles. It might help if you draw them separately. So we have TPS for the first triangle, and that's not the second triangle is PRS. We know this side is 24 inches and this side is 23 inches. And this side is congruent to that side. And then we were going to want to go ahead and mark any other information we know. We know that these two are congruent through the reflexive property, so we can go ahead and mark that. For this, we can use the hinge theorem again, because we are given those two congruent sides. And then we're looking at the sides that are across from the included angle. Oh, I drew that one backwards. I wanted to draw it this way. So they want us to know the difference between these two angles, which is the measure of angle PST and the measure of angle SPR. So fill in the inequality sign and then check your answer. For this one, the one across from 24 is going to be the bigger of the two angles because 24 is larger than 23. So PST is going to be greater than SPR. Our next example, we're going to write an inequality about LN and OQ. So we know this one is 7, this side is 7, this side is 4, and this side is 4. So because we're looking at the included angle, we can again use our hinge theorem. So which one has the largest angle that is included? That would be this one. So that tells us that side across from it, LN, is going to be greater than QO. And that would be our answer. Continuing to our next example, in which position is the distance between the tips of the blades greater? So because these are scissors, the sides are going to be congruent with each other between the two triangles, and we are talking about the included angles. So which one is going to have the greater distance across from it? In this one, it would be the second example. And the reason is because it has, added an extra letter, has the bigger included angle. And that would be our answer. Make sure if it says why, you do explain it. All right, so looking at our next problem. In this one, we know this side length is congruent to this side length. And our third side is congruent, or our second side is congruent between the two. They do give us the sides that are across from them. And we know that 15 is greater than 10. So I want you to write an inequality for the two angles and then check your answer here. For this, your inequality should have said that 60 is greater than 5x minus 20. So then we need to find the possible values for x. So we need to solve this inequality to get x by itself. Now, I know that might look intimidating, but it is the same thing that we would do to solve an equation. So we're just going to go ahead and use our inverse operations. 60 plus 20 is going to be 80. We bring down our inequality sign, just like we would for an equal sign. And then we bring down our 5x. And then we're going to divide both sides by 5. And we are going to get 116 is greater than x. So any value that is less than 16 would give us a possible value for x. One other part of this would be it also has to be greater than 0 because we can't have a negative side length. So anything that we did in this middle column of our problem, we are also going to do on our right side of our equation. So we added 20, we're going to add 20 over here, and we're going to get 20 is greater than 5x, and then we divided by 5, and we would get x is also greater than 4, which would give us the range of inequalities. So normally you would write it out all in one step for the beginning. You would get 60 is greater than 5x minus 20, and then it would also have to be greater than 0. And then you would go through one step at a time. If you add 20 in the middle, you add it on both sides. And then you would get 80 is greater than 5x, which is greater than 20. And then we would divide everything by 5. And that is where we would get our final inequality of 16 is greater than x, which is greater than 4. There you go. All right, our next example. They said let PR equal PS, which they've already marked in our diagram, and the measure of angle PQR is greater than the measure of angle QPS. They want to know which is longer, SQ or RQ. Between the two triangles, we know this is the second side that's congruent, so we can use our hinge theorem. So if we look, the first one that's larger is angle QPR. Oh, I marked the wrong one. This angle. So we have angle QPR, and they said that is greater than QPS, which is on the opposite side. So if the yellow one is greater, that means the side across from that is going to have the larger length. So the answer would be QR or RQ. That would be our answer. Then we're using the same diagram for the next example. Again, PR is equal to PS, and segment SQ is less than RQ. So of the two, RQ is the bigger side. Then we need to look at which one is greater. The measure of QPR, which is this one, or the measure of QPS over here. So we already said the blue one is bigger. So then the angle across from that would be the bigger of the two angles, which is angle QPR. Moving on to our next example, we only have 2 left and then we're almost done. We need to write an inequality for the range of values of x in the diagram above. So we already know it's always going to be greater than 0. Now, if we look between our 2 diagrams, we are given the congruent sides that we need to use the hinge theorem. So we have 9 as a side length and 7 as a side length. Because 9 is greater, we know that angle N is going to be greater than angle K. So we're going to write down the smaller of the two first, which would be 3x plus 18 is going to then be less than the 90 degrees. And we got the second 2 parts by using the hinge theorem. Then we can go ahead and solve. We're going to start by subtracting 18 on both sides. And we're going to get negative 18 is less than 3x, which is less than 72. And then the last thing we need to do is divide by 3. And again, we'll do it for each part of our inequality. And we would get negative 6 is less than x, which is less than, that'd be 24. And that would give us the range of values that x could be, anywhere between negative 6 and positive 24. Our final example, we're going to write an inequality for the measure of angle UST and angle VST. We're using the hinge theorem because we do have the included angles between 2 congruent sides between 2 triangles. So the angle across from the largest side is going to be the larger of the 2. 14 is the largest side, so this is our largest angle. So we know angle UST is greater than the measure of angle VST. And that is our answer. So make sure you get these copied down and then you can use them to complete the homework.